Alright everybody, now you're probably wondering why I just showed a little minute clip of trees. And the reason I did that is because today we're going to talk about square roots. Get it? Trees, roots, square root. Okay, I thought that was funny, but alright. It's worth a shot. Yeah, I have a corny sense of humor, but... Alright, here we go. There are many topics in Algebra 1 and Algebra 2 that require a strong working knowledge of multiplication. Simplifying square roots is one of these topics. So a square root. What is a square root? For many of you guys, first time you're seeing this, it is a value that when multiplied by itself gives a number. So for example, 4 times 4 equals 16. So the square root of 16 is 4. Okay, you're working backwards. So let's take a look at some examples to kind of build on this concept. Alright, so find the product without a calculator. So we're going to go across. We're going to go fairly quick through this so we can spend more time on the harder stuff. 3 times 3 is 9. All's well. 8 times 8 is 64. 6 times 6 is 36. 12 times 12 is 144. 7 times 7 is 49. 5 times 5 is 25. And that lastly, negative 4 times negative 4 is positive 16. And negative times negative is always positive. Okay? So now, we're going to work backwards. That's all it is. It's basically like the reverse of addition to subtraction. So the reverse of timesing something by itself is to square root it. Evaluate the following perfect squares without a calculator. The square root of 4. Can you think of a number that when you times it by itself gives you 4? So for the first example, the answer is just 2. Okay, there you go. Square root of 16. What number times itself gives you 16? Well, kind of the example up here for us, 4. What, like part C, square root of 1, what number times itself gives you 1? Just 1. Square root of 81. 9. 9 times 9 is 81. The square root of 4 ninths. You can break this up so it's square root of 4 over square root of 9. So we can ask ourselves, what's the square root of 4 up top? 2. What's the square root of 9 down low? 3. Boom. Okay. Negative square root of 9. So it's just negative. Square root of 9 is 3. The negative can chill out front. Good. And lastly, it's a little tricky one, but it is a perfect square. The square root of 121 is simply 11. Okay? Awesome. So the square root symbol is known as a radical, and the value that you are taking the square root of is known as the radicand. The imaginary 2, so there's really just a little 2 out here. It tells you like how many times you're timing something by itself. This is called the index. In the problem below, identify the index, identify the index and the radicand. So here's our index. Okay. And then this is called our radical, the square root symbol. Alright. And then this number underneath here is the radicand. Please note that once our index gets above 2, we indicate its value. So you'll see for all these square root symbols, we're never going to write the number 2 down. Here you see it's really, really faint, but up here we never used it. When you start to take cube roots, fifth roots, fourth roots, so on, so forth, and yes, we will get to that at some point, okay, you do write the number out. So for example here, cube root 27, and really all you're doing there is, I know it seems like really complicated, what number times itself 3 times gives you 27? Well, 3. 3 times 3 is 9. 9 times 3 is 27. Okay. What number times itself 5 times gives you 32? Well, that's just going to be 2. 2 times 2 times 2, so on and so forth gives you 32. We can rewrite the product of 2 or more square roots as the square root of the product of the radicands. So in simpler terms, if I have square root of 8 times square root of 8, we can combine them to get 8 times 8, which is 64. All right. So you can combine these things together to make things simplified. All right. I'm hoping you guys are all comfortable with x times x gives you x squared. We'll talk about that more as we go on. Multiply the following square roots. Find the exact product. So here, I can do 7 times 3 underneath the radical. Okay, so that gets me square root of 21. Same thing over here. Root 21 times root 3. I'm just multiplying 21 times 3. So that gets me 63, square root of 63. 4 times 3x, so we got 4 times 3 is 12, and then the x just stays x. Okay. Just to kind of make it a little shorter, 5 times 2 is 10. The only m's I got are right there, and the only k's I got are right there. So I'm going to put k m squared. You only combine them together if they're the same letter. Lastly, for part E, okay, I've got square root of 6 times square root of 2 times the quantity negative square root of 5x. Well, the negative's out front, so I'm going to let that chill out front. Everything else is under the radical. So 6 times 2 is 12. 12 times 5 is 60. And I still have an x underneath there. Okay? So that's all we've got going on so far. Cool. Just simple multiplication. Now we're going to take it up one step, and this is where we're going to spend a lot of time focusing on making sure we get to practice with it. When you take square roots of perfect squares, 1, 4, 9, 16, 25, 36, 49, which you're going to get very comfortable with these. Okay, I'm going to show you guys in a little bit how to get that on the calculator as well. You get integers much like in number 2 above. If we can factor our radicand into the product of a perfect square and some other value, it can be simplified. So our goal here is, for all of these problems, we are looking for perfect squares, okay, some of these numbers that can go into the problem. So here's my example. Square root of 32 equals square root of 16 times 2. So I can break it up. Well, you guys know that square root of 16 is really just 4. So now I have 4 root 2. Okay? So what we're doing is just simplifying things down. Alright, so let's take a look at the first one here. Part A, square root of 72. I'm looking at these numbers. The highest number here that can go into 72 is 36. It can go in 2 times. Okay? All I'm doing is just playing a game of mix and match. Like, how do I find which number can go into it? What's the square root of 36? 6. And this stays square root of 2. So I can simplify this down, but I can't simplify that one down. Now, here's an interesting thing for you guys. If you have a calculator, here's square root of 72. Okay, it's 8.48, blah, 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 blah. And then 6 square root of 8, or 6 square root of 2, rather. Same exact thing. They're identical. Okay? Cool. Root 27, the perfect square up here that can go into it. 9, it can go in 3 times. And you may gladly use a calculator for this to play around with it. The square root of 9 is 3. Cool. Okay. Root 48, play around with numbers a little bit. Eventually we're going to find out that 16 can go into it 3 times. The square root of 16 is 4. Root 3. Okay. Awesome. Okay. So, now, if you get to something like part D, right, you got to really look at some big numbers. So we're going to break this down a few different ways. I know the square root of 100 is 10. Okay? So I know this is 10 right here. But then I can break down square root of 45 again, 9 and 5. So the square root of 9 times square root of 5. Ladies and gentlemen, what's the square root of 9? 3. Okay? Again, I know we're getting just used to this. So now that I have the 10 and the 3 out front, I can multiply them together because they're both regular numbers. So I get 30 square root of 5. I know it's more steps, but when you have big numbers like that, it's okay. Alright? So we're going to stop right here. If I have time, I'll go over these a little bit later on, but for right now I want to focus on these. Okay? Because that's what we need to know. Alrighty? So, okay, good. Keep up the good work, and as always, good luck. We are all counting on you.